Welcome to La Trobe University in Melbourne. My name is Jan Libich, and I'm really pleased to be joined by Associate Professor Frank Jotzo from the Australian National University. Welcome, Frank. Thank you very much for joining us.
Thanks very much for having me. Look forward to the interview.
We're here today to discuss a very topical issue, climate change. And you have a lot of expertise in this area. You've written a lot of academic papers on this, but also in the area of policy making. Recently, you've been one of the lead authors of the Intergovernmental Panel on Climate Change, which is, and we'll certainly talk about this a little bit later. But let's summarize the issue of climate change for us. And we'll talk about both the economics and policy. So can you just summarize it? What's going on? What are the major problems? And so on.
Okay, so let me talk about the science of climate change in just 1 minute, the potted version. We're really talking about the enhanced greenhouse effect. Okay, greenhouse lets energy from the sun in and keeps the heat inside, traps it inside. Now, without this greenhouse effect, the Earth would be too cold to support life. Okay, so we need this for the Earth to be habitable. But what we're doing by emitting greenhouse gases into the atmosphere, principally carbon dioxide, as well as methane and a few other gases, these are heat-trapping gases. They accumulate in the atmosphere, and if you will, they make the wall of the greenhouse thicker, or they make the blanket thicker that we have around the Earth, in the Earth's atmosphere, so it gets warmer.
Is it like kind of when you put a lid on a saucepan and the heat can't come out as much as it would?
It's exactly right. You keep the heat that you put into the saucepan the same, right? You're just making the walls of the saucepan thicker, or the lid seal more closely is probably the best analogy there.
And so what's the problem? What's the problem associated with that? I mean, you know, most people like warm weather, so is that warming actually a bad thing?
Yeah, so first of all, one argument you often hear is that, well, why is the status quo, the current climate that we have, the best climate? Right? Well, the answer is that all of our human infrastructure, our economic infrastructure, the way we live our lives, in fact, humanity itself is built on the current climate that we have. Right? So imagine a drastically different climate, as has existed on the planet Earth in geological time, and the basic preconditions for our civilization and possibly our species to survive are no longer there. Okay, so we're kind of pretty fit for purpose in terms of the climate that we have. Any major deviation therefrom poses a grave problem for many species, humans included. Okay, now in terms of what's actually happening with greenhouse gases in the atmosphere, there is a geological timescale variability in CO2 in the atmosphere. Okay. And we are, through our energy systems, industrial systems, pushing the Earth's atmosphere right out of the boundary of historical precedent over time period for which we can sample atmosphere.
But there are some people who say that, after the last ice age, we did see a warming, but obviously that was of a much smaller magnitude. There was 0.6 degrees and over a much longer span, 2,000 years or so. So what are the predictions in terms of the temperature for the next century?
Very good point, Jan. That's rate of change and potential magnitude of change are really the issues here. So over the time span of just 100 years or so, we have pushed atmospheric concentrations of CO2 to 400 parts per million from an equilibrium level of perhaps 280, right out of the measured envelope of variability over hundreds of thousands of years. And if we keep going like that, if we don't do anything about mitigating or reducing greenhouse gas emissions, right, then the projections are that we might double that concentration yet again over the course of this century potentially.
And what would that mean in terms of the temperatures?
Now, that's where we're beginning to get some uncertainty, because we know from the basic physics that there is a positive relationship between atmospheric concentration of greenhouse gases and temperature, but just what is the multiplicator there, the factor, right, is a matter of empirical contention. Okay, and so the projections for temperature rises differ, right? Could be something like 4 degrees above pre-industrial averages, could be as high as 6, 8, or even higher. Right.
I think the Stern review from 2006, it mentioned that increases in temperatures compared to late 20th century of 5 to 6 degrees Celsius is actually a real possibility, and that's really kind of a massive. But the middle kind of projections would be generally between 2 and 4 degrees by the end of the 21st century?
It depends on what you assume for your emissions growth scenario, okay? And so, you know, I mean, many people latch onto the notion of a potential 4-degree increase, okay? But, you know, the point really is not in the expected mean, right, in what we might consider the most likely scenario. The point actually is in the possibility, use that word just then, right, of a high-end, high-impact scenario, okay? Of course, there's a probability distribution, right? It might end up not being quite as bad as we think, and then we'll be lucky, right? But equally, there's a risk that things turn out worse, potentially much worse, than in our expectation, okay? And so this is really climate change policy as risk mitigation policy, okay? So even if the risk is small, right, perhaps, you know, less than 10%, but if the outcome from that risk is catastrophic, yeah, such as, you know, the end of our economic systems and social systems as we know it, then, you know, as a global community, we would be very well advised to actually take precautionary steps to reduce the risk of truly harmful outcomes.
And there seem to be two types of skeptics when it comes to climate change. I mean, one group that basically denies that anything is happening. What would you say to these type of people? How would you convince them with scientific evidence?
Look at the basic atmospheric physics of the issue. They have been clear and undisputed for the last 200 years. Okay? You put CO2 and other heat-trapping gases into the atmosphere and it'll get warmer. Okay? That is not usually, you know, the point of attack, really. The point of attack on the science is more often along the lines of, you know, what is the contribution that humans are making right now to temperature increases? What about, you know, the short-term movements in average global air temperatures and how that compares to model scenarios, et cetera, et cetera. And there, you know, all you need to know is that the very overwhelming majority of reputable scientists in this area, and we're talking, you know, probably well over 99%, and all of the you know, notable academies of science in the world are unanimous in stating that, you know, climate change is real and it is very, very likely to pose a problem unless we do something about it.
There's a meta-study by Professor Lawrence Powell in the United States. He basically looked at all the academic papers about climate change from about 1991, so over a 20-year period, and he found that out of about 14,000 such studies, only 24 of them actually argued that there's no climate change or they wouldn't attribute it to human action. So there's, as you're saying, it's a lot more than 99% majority. So the second type of skeptics actually goes back to the point that you mentioned. They might admit that climate change is happening, but because there's so much uncertainty around it, they basically argue we shouldn't do anything. We don't know what's going to happen, so we shouldn't do anything. So what would you say to these people?
Look, it's a fine example actually how in an area that is scientifically complex, right, and that is also very complex in terms of how we react to it at an individual basis and how we react to it as a society, right, how in that kind of complex decision-making environment it's quite easy for people to throw sticks in the spokes, if you know what I mean, right? So if you, for whatever reason, right, and there's usually, you know, specific vested interests at play here, right? In an area as complex as this, it is easy to throw confusing arguments into the debate. But, you know, all you need to do is really step back a little bit and take it back to principles, right? And you come back to the issue of uncertainty. Okay, let's grant that this is not, there's no certainty around this, okay? It may be 99%, you know, but there's a 1% possibility that everything will turn out fine. What is the adequate response here for societies? Is it to wait and see whether in fact, you know, the draw will be one out of the 99, and you know, and then bad luck, and wait whether perhaps we get lucky and we get the 1 in 90, 1 in 100 chance, or is the sensible approach to assume that in all likelihood this is a problem and we better get on top of it before it gets on top of us? And the answer is, of course, crystal clear. The reason why we're seeing these arguments, I would say, is fundamentally because doing something about the problem of greenhouse gas emissions, right, will cause substantial changes in some well-defined parts of our economies, right, which in turn have substantial ramifications for the economic value of existing infrastructure and existing structures of ownership and profitability. And of course, you know,
parties involved might not always see that as a positive to them, so they're obviously averse to any sort of...
Yeah, look, I mean, you know, quite obviously, you know, people are putting up a fight whenever there is, you know, a major structural change in the economy. We see that with everything. We've seen this with agricultural liberalisation. You see that, you know, whenever there's a suggestion that government might withdraw subsidies from a particular part of the economy. In most of these cases, it's quite readily possible to come to some kind of arrangement where these interests are being bought off in a way, if you want to say that. But you know, this is something that's actually not just some very small part of the economy, like you know, CFCs were in terms of ozone depleting substances, right? Here we're talking about fridges and firefighting equipment, right? It's a very small part of the global economy. This is bigger, this is more pervasive, and so it's more difficult.
So let's talk about some of the specific negative consequences of climate change. I mean, people talk about the melting of the glaciers, people talk about sea level rising, the Great Barrier Reef here in Australia, you know, extinction of many species, some of the major changes in industry. Can you just talk a little bit about some of these issues? Which are the most important in your view?
Well, what are the most important potential climate change impacts will depend on the specific geographical, other, you know, natural factors and economic factors as well. So it's very location specific. In broad terms, what we're talking about is a warmer climate, okay? And that will have ramification for regional and local climatic patterns as well, right? So
bird migration, those sorts of things.
Well, even before you get to that's before you get to that, right? Climatic changes in terms of the amount of rainfall that you're likely to see in different parts of the world, right? So there will be some areas where there will be more rainfall and the other areas where there will be less rainfall, okay? So just take that as an example. Where there is more rainfall as a result of climatic changes, you will have more runoff and more frequent flooding. Okay, what do you do about that? Well, there's usually infrastructure solutions for that, right? Better drainage, better flood management systems. Perhaps you will need to move your city from, you know, down the river delta to further up the hill. Enormously costly in terms of, you know, the existing economic infrastructure that's there, that you either got to write off and build new, or in terms of additional infrastructure that you've got to put in as a defensive measure. In other parts of the world, it might get drier, and this is a distinct possibility, not a certainty, but a distinct possibility for the southeast of Australia. Right? Now, we already, in a cyclical fashion, here are dealing with shortages, with droughts, okay, and attendant water shortages. Causing problems for both for city water supply and for agriculture. If you had a scenario where that intensifies, okay, you can quite readily see the ramifications for agriculture, where we live and how we deal with our
One of the
affairs.
findings that I found interesting in the recent report of the Intergovernmental Panel on Climate Change, which you were a part of, is that the yield of some of the main crops like rice and so on and wheat is very likely to actually be impacted negatively rather than positively, and the report actually mentions that some areas can have a positive impact, but overall it's more likely than not that there'll be a negative impact. Again, there's a high uncertainty around that, but as a risk mitigating measure, I think that should probably be addressed.
Yeah, look, I mean, food security is usually seen as one of the big sort of meta factors that could pose a strong risk from climate change, right? So if we do see crop yields drop substantially as a result of climatic change, then it has ramifications throughout our economic systems, and not just the economic systems, but also our social systems, right? So that can cut straight at the heart of how the world actually works, where people live, where there are wars between different groups of people, okay? Migration pressures, all the rest. We have to see this in a systemic context. And, you know, I mean, Professor Garneau, for example, in his 2008 climate change review for Australia.
Which you were a part of.
Yeah, I was very lucky actually to be in a position to help advise on that review. And, you know, Professor Garneau always made sure to place impacts on Australia in the regional and global context, right? So we trade a lot with the rest of the world, right? We rely on investment from other parts of the world. We are an immigration country, right? And so all of these things could be affected potentially in a very substantive way as climate change affects the countries that we are connected with through trade and investment.
Well, if we were to put a value on the cost of climate change, and obviously the cost of extinction of many species and so on, all these kind of non-economic costs are major, but even if someone's an economic rationalist and all they care about is the hard economic numbers, what are the kind of costs of not doing anything to prevent climate change?
So here we are, right, in one of the big controversies this year around the release of the Intergovernmental Panel on Climate Change Working Group 2 report on impacts and adaptation, economic estimates of damages. Now, really complex, right? And I would, you know, anyone who watches this and the audience, right, when you see these numbers that say economic damage from climate change in the year 2100 will be X% of GDP, right? Take them with as big a grain of salt as you can possibly find, right? Because, you know, we're trying to extrapolate out what our economic systems might look like in 50, 80, 150 years down the track. And if you backcast that, right, if you were in the year 1910 and you try to imagine the economy of 2013, you would have come up with some wildly distorted picture that has very little to do with, you know, where we're at now, right? No one would have predicted.
Are you saying you wouldn't have predicted the iPhone and... You know?
Yes, I am saying that, indeed, right? And so, and then you go, right, and say, all right, so we take that hypothetical future economy that we don't know what it'll look like and impose climate change on top of it, right? And we measure the difference. That's essentially what goes on in these economic models. So we really can't say much, right?
But if you had to put a number, if you had to kind of come up with some, or maybe a range of estimates, I recall that the Stern review worked with the number of maybe 5% of GDP kind of lost indefinitely, and maybe if you include kind of various other risks, it could be as high as potentially 20% of GDP. So we're talking, you know,
that's right. So
large losses.
So if I had to come up with a number, and I will not come up with a number because, you know, if I'm a skeptic of our capability of modeling these things in terms of the economic effects and economic cost and benefits, right? Talking about these cost estimates and the ranges, the point really is the range, right? So Stern's number, headline numbers were, you know, 5%, right? Climate change impacts, right? Up to 20% once you include equity adjustments and once you include uncertainty, some stronger weighting on more extreme impacts, right? And this is and once you include some valuation of the non-market impact. So that's a ratio of 4:1, okay, at the sort of more inclusive estimate compared to the bare bones kind of just market values estimate. And that's those three things, right? Let me take them one by one. Valuation of non-market impacts, that's the value of your ecosystems, the value that we might place in Australia on the existence of the Great Barrier Reef, that perhaps other people in other parts of the world might place on the existence of Australian animal species, right, that might go extinct. Okay, so we don't trade these things in markets. Nevertheless, it's probably undisputable that as societies we place some sort of value on them. Yeah. Secondly, equity, right? So straight down the line, economic model, right? A dollar is a dollar, right? Someone loses their house in a suburb, with a view of the ocean in Brisbane, of the river in Brisbane, right? $2 million loss, right? If it's a nice big house somewhere. Someone loses their house in a river delta in Vietnam or Bangladesh, $20,000 loss. Okay, so is one 100 times worse than the other? Well, probably not, right? So we should be placing a greater value on the loss imposed on someone on a low income, right? So we need to adjust these estimates. Finally, the value of insurance, right? Or the disamenity from the risk of really severe climate change impacts, right? Back to the issue of a perhaps low risk, a risk in any case, we don't really know how large the risk is even, of a very severe impact, and that needs to be reflected in our overall estimates.
In this context, you mentioned, natural disasters like floods and droughts and so on, cyclones. Can we identify and can we attribute a specific event like that to climate change, or what does climate change actually predict about these catastrophic events? That they'll be more frequent, or they'll be greater in magnitude?
So, in general terms, under scenarios of global warming and climate change, you would expect an intensification and greater frequency of many types of extreme weather events. Okay,
so it's
I'm choosing my words very carefully here, and I would like to reiterate that my field is economics and policy and not the natural science of climate change, right? But greater intensity and greater frequency of some types or many types of extreme weather events, right? And hence, typically a greater damage bill. And I think one of the more straightforward examples in the Australian context, in any case, is bushfires. Okay, so hotter summers will mean more frequent and more extreme conditions for bushfires, large-scale burning of natural forest land. Okay, with the attendant cost for infrastructure in terms of housing, lives and health and emergency services.
So we talked about the cost of not doing anything. What are the estimates of the cost of actually doing something, of this mitigation? And we'll talk a bit later about the specific possibilities for climate change mitigation. But what are the costs? They seem actually, this is another argument of the skeptics. They go like, oh, we would have to go back to the trees. That would just be too costly for us to change our lifestyle. Is that really the case?
No, it's not. And really the rather wonderful thing is that, if you allow me to draw two graphs here in the air, right? One is of emissions going down.
You're a true economist.
Right? One is of emissions going down in a baseline case, and one is of economic output emissions going up, economic output going up. That's business as usual, right? Now our mitigation case, right, where we're reducing emissions, is emissions going down rather than up, down, right? And economic output keeps going up. It's just marginally less in terms of the rate of increase over time. IPCC estimates from several hundred models and modeling runs, right, tells us that the economic cost, if you want to term it that, in terms of foregone increase in GDP, is something below 0.1% per year. Right? So rather than the world economy growing by 3% per year, if that's the number you want to assume for the next 50 years or so, it would increase by 2.9% a year. Or in other words, the world would double economic output, the world would double GDP and consumption in the year 2051 rather than in the year 2050. Those are the kind of economic cost estimates. Of course, around central estimates like that, there's a lot of uncertainty yet again. Some models say it'll be more than that. Other models say it'll be even substantially less than that.
I think this is actually a lower estimate than what Stern had in his review. I think generally it was more like a 1% GDP. The estimates, if I'm
so this is an important distinction. The way that the GDP costs are normally reported is in terms of the difference in levels at a particular point in time, right? And so the IPCC numbers, the envelope given there, is between 2 and 6% of GDP at 2050, okay? Right. Comparing two alternative scenarios at a point in time. Now, if you take that back to annual growth rates, then you arrive at less than 0.1% per year. Right. So actually, there's some studies done, including by a colleague at CSIRO, Steve Hatfield-Dodds, on how people perceive these numbers that are being reported, right? And there's often a confusion in terms of the rate over time, as opposed to the 2 to 6%.
The bottom line is that these numbers, however we report them, would seem to a general public would seem fairly low. I mean, we're talking about big changes that seems, and you seem to suggest that they have a very low cost. How can you explain the intuition? Why is that fairly major changes would have such a small
The cost
impact?
is low relative to the size of the global economy and relative to the size of any particular economy, okay? The cost is large if you go down to the micro scale, right, and look at what needs to happen in any country's energy supply system, in any country's heavy industry sector, in any country's building sector, in any country's transport sector, right? So once you get down and boogie at the sector level, the costs suddenly don't look so small, right? Because you're talking about hundreds and hundreds of billions of dollars of investment per year that need to go into a modernization of these systems, okay? So when you're thinking about, the electricity supply sector of a country where fossil fuel plays a big role, such as Australia, such as China, such as the United States, okay? And you're thinking, okay, so we're taking a 2-degree scenario, strong global mitigation, which means that, all other things even, we will probably have to turn a very highly intensive, carbon-intensive power sector into an almost zero carbon electricity supply, right? From high carbon to no carbon in the space of 30 or 40 years. Exactly, that's right? So what that means is that we would need to stop investing in fossil fuel generation assets pretty much now, right? Or very soon, and go for zero carbon options instead, perhaps with lower carbon options such as gas and very high efficiency coal for a limited period of time instead. Okay.
But my reading is that technology is really the key, that the fact that technology is really evolving quickly, that is what is driving the cost down.
That's right. And so, at the end of the day, changes in consumption patterns and habits have some role to play, right? But really it's about the technology as to how we provide the services, okay? People will want to live comfortably, right? In houses and flats, right? People will want to get around, right? We will want, the world will be richer and people will increase their demand for travel, right? Unless, of course, we have some further enormous improvements in telecommunications technology that may reduce travel needs by some extent, right? So all of these, all of that will go on. The question is, how do we supply that, right? So to the extent that all of this uses energy, how do we get to a point where we provide most of that energy in a carbon neutral way? Okay, and the technological opportunities are already there, right? We would not need further technology development than what we already have right now in order to make that transition for the world. It would just be much more expensive than, on current evidence, the governments of the world are actually prepared to commit their economies to do, right? On the bright side, of course, the costs of these new clean technologies are coming down all the time, right? Solar panels these days cost a small fraction of what they cost 2 decades ago.
Let's talk, and now maybe a little bit more briefly, because we've got a lot of ground to cover, just talking about the different mitigation strategies. I mean, some countries have emissions trading schemes to encourage the kind of innovation and movement towards cleaner energy. Some countries have environmental taxes, there's direct action, there's geoengineering solutions. So what can you maybe just briefly talk about those, and what do you think is the way forward in terms of climate change?
There's a great diversity of policy instruments that countries use and that countries can use potentially, right? And they are, the choice of these policy instruments is tightly linked to policy objectives, right? So in the actual policy making, it's not always just about reducing greenhouse gas emissions, right? It's about co-benefits, right? Such as reducing air pollution is a very big motivating factor in China right now, in terms of their attempts to limit the growth, successful attempts in limiting the growth of coal consumption in China, right? Clean up the air pollution, that's really a big problem there. And it's also, of course, also a tradition, a function of tradition, a function of existing institutional frameworks, and at the end of the day, politics as well, as we see in this country. So, diverse policy approaches. From an analytical point of view, right, in a market economy, we will always come back to the conclusion that putting a price signal on greenhouse gas emissions will be the backbone and the core of a cost-effective strategy to reduce emissions, okay? So price signal, we mean either an emissions trading scheme, right, where government issues permits and market participants, companies can trade these permits with each other because they have a scarcity value.
The current system in Europe and
exactly,
Australia.
That's right. And a system that has been used for other pollutants as well, and that many other countries are considering or implementing. California among them, Chinese pilot schemes for emissions trading.
Or conversely, Korea, Mexico, a few other countries.
That's right, that's right. So there's a significant amount of uptake of this policy instrument. Conversely, you could also, or you can, many countries have, put a carbon tax, a tax on emissions.
And under some circumstances, it would have a very similar effect, or identical.
Well, at the end of the day, the effect is the same. The emitter, the factory, the power station that puts greenhouse gases into the atmosphere, faces a price signal, right? There's an opportunity cost of doing this by cutting back, by putting in a more effective, a more efficient piece of technical gear, by switching from a high carbon fuel to a low carbon fuel. They can save themselves money because they have to pay less carbon tax, they have to buy fewer of the emissions trading permits, okay? And to the extent that they do still emit greenhouse gas emissions, they will pass that carbon cost on to their consumers, right? And the carbon intensive products will go up in price, and the low carbon intensive products will go down in price. And consumers will then have an incentive to actually modify their choices in that regard. So it goes right through the economy, relatively small administrative effort, and you will be very hard pressed to find an economist who says that this approach is not the right one, and some more direct regulatory or subsidy approach is superior.
But it seems the devil is really in the detail, because many would argue that the European emissions trading scheme is not really performing very well and so on. But unfortunately, we don't have time to go into that level of detail. But let's just think about the global action. I mean, clearly that's a global problem, so we need a coordinated action across all governments. Have there been enough of an action? What does the future hold?
So to come back to your non-question about the EU ETS, what's going on there is that you have a severe economic downturn and a fixed emissions target, right? And so much less needs to be done to actually achieve that short-term emissions target to 2020. And there's a host of non-pricing policies in existence as well. Regulation for energy efficiency, massive subsidies for the deployment of renewable energy, and that leaves very little for the emissions trading system to do. And so it does very little, and the prices are very low, and the instrument isn't working. Okay? So if you infuse that instrument with ambition, then it would work again. Now to the question about international cooperation.
Well, let me just add that Australia is the opposite case. The emission trading scheme seems to be working. The price is now about 3 times what it is in Europe, but the government is actually trying to scrape that scheme and move into direct action. But anyway,
well, it has some effect right here, right now.
And you've been very critical of this kind of proposals. But let's go back to the global kind of cooperation and the prospect of actually dealing with climate change on a global scale. We've had the Kyoto Protocol. I mean, can you just maybe outline a little bit about the past and now the future in terms of the future targets and whether we're moving in the right direction?
Yeah, so the world community has gone through this amazing journey, right, of elevating climate change to a position of central importance for the cooperation of nations, and we were really there in 1992 at the Rio Earth Summit, right? Out of that was born the Kyoto Protocol with quantitative targets, legally binding targets for greenhouse gas emissions.
Everyone ignored?
But only for the developed countries, right? And without ratification by the US Congress. And so really it was a bit of a house of cards. And since then, the journey has gone further than that, and in a sense back to the national level as well, with the realization that quantitative targets negotiated in the middle of the night at some UN conference, right, don't necessarily mean that much once they're taken back to the cabinet rooms in national governments and exposed to all manner of economic and political change that comes afterwards, right? Now, the current thinking really is that what needs to happen is for countries, governments, leaderships, to come to their own domestically determined positions on what they can do and what they're comfortable to do, right? And take that to the international table, show it to everyone else and say, look, this is what we intend to do. What do you intend to do? And you, slacker over there, you should be doing something as well, right? So, which is actually a much more traditional approach to international negotiations and diplomacy than the kind of approach that was tried and that, to a large extent failed at Kyoto.
It still doesn't seem to be dealing with the main problem, which is the prisoner's dilemma. If, you want everyone else to mitigate, but because of the cost, you would prefer to free ride and not mitigate. So that seems to be the main problem behind kind of inducing cooperation across countries.
Yeah, certainly. So the basic theory of why all this isn't working is that each individual country is too small a decision-making unit, and so their own contribution to solving the global problem is a relatively small one, and so too much of the overall benefit of their action gets diluted to everyone else, and that's why you need cooperation. But cooperation is hard to achieve because everyone just wants to free ride on everyone else's effort. That's a simple game theoretic kind of caricature description of what we have here.
I think Stern called it the greatest
externality of all time, like this, right? The greatest externality the world has ever faced. Certainly that's true. However, if you really get an understanding what goes on in international relations, the picture really isn't quite so simplistic, right? There are relationships that states have, there is reputation at stake, there is, this is not a one-shot game, right? This is a repeated interaction, and it is a game of mutual assurance. Right?
Well, China seems to certainly be kind of breaking this prisoner's dilemma because they're moving in a direction climate change mitigation more strongly than one would expect.
China is in a sense reluctantly, right, moving itself into a leadership position globally on climate change. Okay, so reluctantly, right, because for so long China has seen itself as a developing country that will like other developing countries, go and do something once the developed country group have really gone ahead and done something useful and deep about that. Instead, the situation we have is the developed country group as a whole, with great differences between countries, have done, something, but really not an awful lot on climate change mitigation, right? And we're now in a situation that the global problem really cannot be solved unless China and other industrializing and developing countries do what needs to be done. Practically all of the incremental growth in global greenhouse gas emissions from year to year now comes from developing countries.
But China is, I think, the biggest emitter in the world. If you just
China
look at the
is
total. But they, the argument they had is that they want the rich countries to do something first. This is justified in the sense that they still have China, I think, per capita emissions are still about 25% compared to the US. I think India's are like 8%. So, we still, they're kind of entitled to have their share of emissions in some ways.
China is now above the global per capita average. And so when you think of a scenario where per capita emissions peak at some point and then decline, as they will have to for any kind of meaningful global climate change mitigation, then Chinese emissions will have to come down faster and more strongly than global averages, right? So, but more to the point, in China there's an increasing realization that this presents an opportunity. Okay, so Chinese leadership these days is strong on quality of growth. Okay, they don't want to be the kind of heavy duty workshop of the world anymore, right? They want to lead in services, in high value added manufacturing, and clean energy is a tremendous opportunity for China. China is already the market leader in wind turbines and in solar panels. Okay, so if China can go ahead and infuse stronger climate change action globally, that will increase the global demand for wind turbines and solar cells, which is good for Chinese manufacturers, right? Same for nuclear power stations. Okay, same in a Chinese industry policy type view for other emerging zero carbon technologies that are coming or that may come in future.
Now, before we move, we're running out of time. Before we move to the audience for questions, let me just ask, we talked about what countries can do, what policymakers can do, but there's, I think, a lot we can do at the personal, at the individual level to actually help the environment. Recycling and all this. Can you maybe just mention some of the things we could do? At the beginning, you said that these are not so important compared to the changes in industry and so on. But I would argue that, a lot of the emissions come from, for example, the meat industry. In fact, this is probably the greatest emitter, even bigger than transportation. So is there something, should we change our diet and eat less meat, or should we maybe, ride the bicycle more? What are the things that we could do to kind of help the environment kind of adapt and slow down the process?
Jan, this always creates among the most vigorous debate and discussion precisely because it takes it down to the individual level. And I remember back to 2008 with the release of the Garnaut Climate Change Review, one of the really big headlines in the media was Garnaut says we should eat kangaroo rather than beef, right? And this is really, yes, of course, here's a red meat and another red meat. One causes tremendous amounts of methane emissions, the other doesn't, right? And it's a logical conclusion. But there was no sense of prescription that individuals should do this, that, or the other. The point is, if you had a rational system and a cost-effective way of dealing with greenhouse gas emissions in terms of a pricing system, then beef would rise in price and other substitute meats from non-ruminant animals would fall in price, and people would make their consumption choices along those lines.
Even if you didn't have that, if you just scrape many of those farming subsidies and water subsidies and so on, the price of meat would be much higher than what it is now, and obviously consumption would fall.
Perhaps talk to the European Union in particular about that. No, but seriously, in terms of individual consumption choices, right? It is, at the end of the day, constrained by the system that we live in, right? However, there are big opportunities at the individual level, in particular for energy efficiency. So the purchasing decisions that we make for appliances, right? The slightly more expensive fridge or television that uses less power, right? Cars, right? Large car, small car, hybrid, non-hybrid, and housing. So especially freestanding houses and especially insulation, right? Those are the things where individuals can make really big differences in terms of the energy use footprint and thereby also the carbon footprint.
Well, in terms of academics, I was really surprised to find out that a laptop computer generally consumes only about 10% of the desktop computer. So and there's a lot of things we can. One of the other things I have to share it with the audience here. One of the reports that I've read was looking at. It was in the UK. Was looking at the energy consumption associated with kettle. Boiling tea. Yeah. And basically it found that about a third of all the energy is wasted by overfilling the kettle. And that third of energy would actually be enough to cover half of all the street lighting in the UK. So there's a lot of things we can do even when we fill up the kettle to boil tea. I mean, there's many things we could do to really help the environment, but that's probably for another debate. Can I now turn to the audience and maybe have a couple of questions for our speaker?
My question's with regards to implementing a price system. If people aren't willing to pay for, say, we're talking about beef and compared to lamb's a lot better. If people aren't willing to sacrifice beef consumption in favour of lamb consumption because lamb's too expensive now in terms of their utility, what makes us think that they're going to vote to arbitrarily change that price? How do you transfer this idea that there is a price there we can put on there in terms of convincing the voting public to actually implement this price if they're obviously not willing to do it of their own accord? So
the point here really is that we need to think in terms of changes in relative prices, okay? Where one price in the economy increases, another decreases, okay? Where government raises revenue from a tax, government has money to lower another tax or to provide extra public services. Okay, this is the point that I think we really, as economists and that as anyone working in this kind of policy space, and in fact many other walks of policy life, we need to work harder to get this point across in public communication, because the example in Australia, or the experience in Australia with the carbon tax debate was that a substantial proportion of the population seemed to have only got the message that the price of some goods and services, principally electricity and gas, will go up, right? Stop, end of story. Well, in reality, of course, not stop, end of story, because relatively speaking, the price of other goods and services will decline, right? And the money from the increased price of electricity and gas goes somewhere, right? And the majority of it ends up with government, and government can cut taxes, in this case income tax, and increase welfare payments. So I think I really have to say that as a community of economists, I think in public communication we have to a significant extent failed on that front.
Sorry, I don't think you quite answered my question.
See, I failed again.
My question is, if people are not already willing to change their consumption patterns, what makes us think that they're going to vote for the government to force them to do it?
Well, if they have to pay double for the price of beef, I think that's what's going to change their mind. So that was the relative price argument.
You can only do that if you vote for it.
Yeah, so voting for change, and I mean, there it comes back to a whole range of relatively soft arguments as to why Australia or any other country would want to do something about this issue, right? And it comes back to the free rider problem that we discussed earlier. And I think in any society you will find people who take a strong moral or ethical, value-based position to these issues, and they say, well, I want to be part of a nation that does what is right, okay? And of course, what is right will then again differ, but there will be a sort of a broad range of features that most people will agree on what's the right thing to do, as in, the right thing is to contribute to the global good, the right thing is to perhaps contribute more strongly to the global good than a relatively poor country such as India, etc., right? And there will be other people who will put the emphasis more on the near term and more on their own individual situation, and who will say, well, I don't really care so much about the greater global public good and our nation's role in it. What I care about is my financial position at the end of the year, and they will tend to be less enthusiastic or in fact actively opposed to such public good provision. But this is not the first time that any nation comes to a decision point like that. These public policy decisions with their international ramifications are being made all the time. And just think of any nation's or Australia's decision to make a contribution to an international security effort or in fact to ongoing wars, right? We send soldiers there, we make enormous contributions financially in terms of equipment to the effort that, rightly or wrongly, is going on in different parts of the world. And these are complex issues that are being worked through the public policy, the public debate, and ultimately the electoral process as well.
Do you have another question?
Yes. I think what was rightly sort of pointed out earlier, that most of the carbon emissions that we are getting in the contribution to pollution isn't that of the individual level, but that of the corporate level or industries and such. And so that sort of brought me to sort of an analysis of my father, who actually works in fracking, in the oil industry and the gas industry and things like that, alternative, so-called greener, healthier forms of extracting minerals or so forth. In fact, they're quite harmful to the environment. In particular, if you look at the sort of coal seam gas or things like that, you have cases in the United States where it's pitched as it's better for the environment, but you have cases where there's high levels of toxins being injected into the earth, and you've got cases where there's high levels of earthquakes now being seen throughout the US, and mudslides and sink pits and things like that. And we've just recently in Australia allowed fracking on the Great Barrier Reef, and there's already been seen, environmental damage and ramifications by the locals in those regions. So maybe if you could give me an analysis of, we have alternatives to what's happening now, but even maybe a better analysis of what's supposedly green or not.
What's green or not? I'll start, with the start of your question about individual action versus systemic. That's actually a nice example. Where does our energy supply come from? Where does our gas come from? Is it traditional natural gas, or is it unconventional gas, as it's called, shale gas, coal seam gas? And I live in Canberra, and it gets pretty cold in winter, and so I turn up the heating. In my house, it's gas. Okay, so I don't really have a choice as to how that gas is produced and where it comes from. The choice that I do have is to invest in better insulation of my house, right? And persuading my kids to wear a jumper rather than turning the heater up even more, right? In terms of where the gas comes from, this is really unconventional gas is a wonderful example of the trade-offs between different types of environmental and societal objectives, right? So we've really seen the gas boom in the United States, okay? And it's done tremendous things in terms of bringing the US greenhouse gas emissions trajectory on a significant downward trend, right? So about 2007 was peak CO2 for the US, right? And it's practically certain that this will be the case, probably forever, right? And gas has had a lot to do with it, because it's just simply uneconomical at the moment to build new coal-fired infrastructure in the US because gas is cheap because of fracking. But of course, all sorts of local environmental problems that you have as a result of it. How big a value should you place on CO2 as a global long-term environmental problem versus, water pollution, loss in local amenity because of, everything that goes on with gas exploration? It's an open question, and I think that's ultimately for each society, each jurisdiction to determine. I don't think there's any, objective answers to that question.
Well, this is the same thing is true for all these geoengineering solutions that have been floating around, pumping sulfur in the air or mirrors, those sorts of things. I mean, we don't know exactly what the possible negative consequences might be, and we're not going to find out until we do that. Let's just maybe have one last question.
I've been studying the electricity supply chain or something, and I'm finding that there's a lot of policy intervention downstream because it's an oligopolistic market, fossil fuels, etc. But at the distribution stage, which is a natural monopoly, I find that there's actually not a lot of government intervention there. And so I'm curious to understand in your mix, or in the policy mix of adaptation and mitigation, how do you explain that? Because it's the same electricity that's flowing, but there's a lot more happening at different stages of the supply chain. So when you mention sector, I think that's a bit misleading, but I don't think that it's sectoral, it's almost at a different stage of the value chain.
Okay, so let me just talk about the electricity supply system and markets for a little bit. So I'll take your question as an excuse to delve into that a little bit. Okay, so what you have is you've got generators of electricity, right? Both high in carbon and low in carbon, and you've got a national or quasi-national market in electricity, wholesale market, spot prices, in which the distributors and retailers buy their electricity and then sell it onwards to you. Most of the cost you're paying in your electricity bill is not actually for the generation of the electricity, it's for the poles and wires and the distribution network, right? So really overwhelming majority of that. Now, as the electricity system changes its structure, its composition, right, with a greater share of renewables, solar, wind in the system, the cost composition in the system changes as well, right? Because these are, practically zero running cost options, right? All the cost in the renewables, practically all the cost, is in the initial capital investment. Once the thing is there, when the sun shines, it'll produce electricity that won't cost a cent extra. However, to run a gas, or to a lesser extent coal-fired power plant, costs you, right, when you run it, because you've got to put fuel in, and there's also maintenance costs related to the running of these equipments, right? And so you've got a market structure there, and I think you alluded to that, where the pricing for electricity is determined on the variable cost, okay? Because it's a wholesale market, competitive, and the marginal producer, in terms of the highest marginal cost, determines the price, okay? And this is becoming an issue in countries where the share of renewables is a very high one, right? So effectively, Germany, for example, with very high subsidies for renewables, seems to be coming to a point where the returns for electricity generator become very, very low, and may in future become so low that it's actually not viable to invest in further renewable generation capacity because the payments for it just won't be there, okay? And so, people at all ends of the spectrum in electricity markets are coming to the realization that the current market model is not one that is suitable for a system that has much more renewables in it, and or suitable for a system where electricity demand is falling, as it currently is in Australia. So we might see different models of how electricity markets are organized.
Thank you. I'm afraid we're out of time. Professor Frank Jotzo, let me thank you very, very much for your ongoing effort and both on the research as well as in the policy making arena to help to deal with climate change. And let me wish you, as well as the rest of us, that your efforts will actually be successful and will ensure a bright future for our kids. So thanks very much again. Thank you for coming to talk to us today. Thank you.
Thank you very much, Jan. It's a tremendous thing you're running the series here. And thanks for having me, and thanks for everyone in the room.
Thank you.